Hi students and friends, welcome to the channel Learn and Teach by Sir Ayaz. This is your host Sayyid Ayazuddin Haider. This time I have selected the past paper for 9701, that is A levels chemistry, and the paper I have selected is paper 42. It's of March 2024. So let's get started. This is a paper. You know the marks for this paper, it's 100 marks paper. It's March 2024. It's 42. It's of 2 hours. Time is 2 hours. Questions are structured based. Number 1. Potassium iodide Ki is used as a reagent in both inorganic and organic chemistry. A. Ki forms an ionic lattice that is soluble in water. Number 1. Define enthalpy change of solution delta H solution. Now, for the definition should be enthalpy change when 1 mole of a substance, you can even write solute, dissolves in water. Part 2. KIS has a high solubility in water, although its enthalpy change of solution is endothermic. Explain how this high solubility is possible. Now you will refer change in entropy. It should be positive. That's why enthalpy change of solution is endothermic. You can even say the increase in entropy is greater. And that's why delta G is negative. When delta G is negative, it means the feasibility is high for the Ki to get endothermic process. Delta S is positive, or the increase in entropy is greater. Delta G is negative. Part B, table 1.1 gives some data about the halide ions Cl negative, Br negative, and I minus, and their potassium salts. So here's the table 1.1. Number 1, explain the trend in the enthalpy change of hydration of the halide ions. If you see the change is that it becomes less negative. So you can say if it's becoming less negative, it's becoming less exothermic. It must be due to the less attraction of the ion to water. Let's start with the charge density. Charge density from Cl minus to I minus decreases. It's because of the size. As size increases, the charge density decreases. So hydrogen enthalpy less exothermic, as you can see from the table. Hydrogen enthalpy is less exothermic because of less attraction of ions to water. Moving to next part, number 2, the delta H solution values of these potassium halides are almost constant. Use the delta H hydration and delta H lattice data in table 1.1 to suggest why. You see the difference? If you look at the difference between these two, minus 364 to minus 335. 364 minus 335, it's of 29. Difference is 29. What about the lattice energy? 701 minus 670. It's 31. It's almost same. What about the enthalpy change of hydration between Br minus and I minus? 335 minus 293. It's 42. And on the right hand side, that's lattice energy of potassium halide, that's between bromide and iodide. 670 minus 629. It's 41. It's also almost same. So difference is same. You can say it's constant. Difference between delta H lattice and delta H hydration, it remain constant. Or they are becoming less exothermic by same margin. You see, this is the margin, 29 for change of hydration between Cl minus, Br minus, and 31 lattice energy between Cl minus, Br minus. Same scenario with Br minus and I minus in case of enthalpy change of hydration, 42, and lattice energy for Br minus and I minus 41. It's almost constant or same. So you can write or delta H lattice and delta H hydration become less exothermic by same margin. Moving to next question. Number 3. The enthalpy change of solution of Ki is plus 21 kilojoule per mole. Use this information and the data in table 1.1 to calculate the enthalpy change of hydration of potassium ion K plus G. Recall the formula, which is delta H solution is equal to delta H hydration minus delta H lattice. Delta H solution is given, so you can write here plus 21 gives, for delta H hydration, I will write delta H hydration for K plus, it should be added to delta H hydration for I minus delta H lattice for potassium iodide. Where is it? If you look at the table, here it is. This is iodide, potassium iodide, minus 629. So I will write minus 629. What about delta H hydration for iodide? it's minus 23, minus 293. So there must be minus 293 here, plus 21 is equal to delta H, hydration, K plus, minus 293, minus minus plus 629. Finally, delta H, hydration, K plus becomes plus 21 plus 293 minus 629. So 21 plus 293 minus 629 minus 315 kilojoule per mole. This must be the final answer. Next question. Number 4. Solid PbI2 forms when Ki aqueous is mixed with Pb2 plus aqueous ions. The solubility product Ksp of PbI2 is 7.1 into 10 raised to the power minus 9 mole cube per dm with the power minus 9 at 25 degrees centigrade. Calculate the solubility in mole per dm cube of PbI2 solid. So for this, you should know the formula, that is Ksp, constant for solubility product, and it must be Pb plus 2, and we have I minus square. Because this is the equation. PbI2 solid plus H2O liquid gives Pb plus 2 aqueous plus 2I minus aqueous. So Ksp is given, that is 7.1 into 10 raised to power minus 9 gives, we need to find for PbI2 solid. So if you'll consider Pb plus 2 as X, then Y should be considered as 2X because of the power. See, there are 2 moles of iodide, so you write 2X, and this must be, square must be taken. So it will become 7.1 into 10 to the power minus 9 gives 2X whole square means 4X square, and when you will multiply this by X, what you will get? You will get 4X cube, or X cube is equal to 7.1 multiplied by 10 to the power minus 9 divided by 4. So 7.1 divided by 4, 1.775. 1.775 into 10 is power minus 9. So we need to take under root cube for this. Under root cube for this. So if you'll take under root cube of this, you will write here under root cube of 1. 775 with the power of -9. Okay, I have the answer with me. I don't want to waste time on this. I have the answer with me, and the answer is 0.000126 mole per dm cube. This will be the final answer. If you'll do this using the scientific calculator, you will get this answer. Moving to next question, the ionic radius of Pb plus 2 plus is 0.120 nanometer compared to 0.133 nanometer for K plus. Suggest how the delta H lattice of PbI2 differs from delta H lattice of Ki solid. Explain your answer. You can refer to charge or ionic radius. You can see the ionic radius. The ionic radius for Pb plus 2 is smaller as compared to K plus, so which means it has greater, and furthermore it has greater charge as compared to K plus. So you can write Pb plus 2 greater charge than K plus because Pb plus 2 has smaller ionic radius than K plus. Therefore, attraction between Pb2 plus and I minus is greater. Therefore, attraction between Pb plus 2 and I minus is greater. You can even refer to the lattice energy. It should be more exothermic. Or lattice energy is more exothermic, more negative. That is the energy released when the electrostatic attraction is formed between Pb plus 2 and I minus. Part C. Ki slowly oxidizes in air forming I2. Reaction 1, 4Ki plus 2CO2G plus O2G gives 2K2CO3S plus 2I2S. Delta H for this reaction is minus 203.4 kilojoule. This is kilojoule per mole. Table 1.2 shows some data relevant to this question. Remember, the standard entropy is given in Joule Kelvin per mole for this. Number 1, calculate the standard entropy change delta S of reaction 1. You know the formula, standard entropy change is equal to sum of standard entropies of product minus sum of standard entropies of reactants. So putting the values, what we will get, for the convenience I am writing the reaction here again. We have 4Ki plus 2 CO2 plus O2 gives 2 K2 CO3 plus 2 I2. Okay, so the products, sum of standard entropies of products. So we need to multiply 2 by 155.5. 2 multiplied by 155.5 plus 2 multiplied by 116.1. This is for I2. This is the value for I2. And this one, first one is of K2CO3. This will be the product side minus sum of standard entropies of reactants. So we have 4 Ki. So 4 multiplied by 106.3 is it, plus we have 2 moles of carbon dioxide. So 2 multiplied by 213.6 plus, then we are left with O2. We are left with O2, so you write 205.2. If you solve this, what you will get? So in the end, we will get the answer that is minus, I have already done this, 514.4 joule per Kelvin per mole. This will be the final answer for this one. Next part, number 2, use your answer to C1 to show that the reaction 1 is spontaneous at 298 Kelvin. That is at 0 degrees centigrade. So we need to prove it. We have the formula. We have delta G gives is equal to delta H minus T delta S. We need to calculate T. So you write or T is equal to delta G minus delta H divided by delta S. So we have already calculated delta S. What about delta H and delta G? With delta H? Delta H is provided. That is delta H. Delta H is given. This is minus 203. So we need to calculate delta G. So placing the values again. So I will write delta G is equal to minus 203.4 minus, we have 298. 298 is Kelvin, is the temperature. Now, delta S, look at the value, it's joule per Kelvin per mole. So we need to convert this in kilojoules. So for this, we need to divide it by 1000. So I will write minus 514.4 divided by 1000. So in the end, I'm getting what I'm getting. I will get, I will do this for you. Minus 203.4 minus multiply by minus becomes plus. So what we have? We have 514.4 divided by 1000 multiplied by 298. 153. 153.2914. Sorry, 12. It's 12. So we will add this 153.2912 minus 203.4. So minus 50.1088 minus 50.1088 kilojoule per mole. So negative means it's spontaneous. The value of negative indicates spontaneous. That is, it will take place by itself at 298 Kelvin. Number 3, the group 1 carbonates are much more thermally stable than the group 2 carbonates. State and explain the trend in thermal stability of group 2 carbonates. You know the thermal stability, it increases down the group because the cation size increases. If you see the group, this is group 2. Cation sizes for this, they all form cation with the +2 charge. The cation size increases. So it's less likely they become less polarizable by the anion, that is carbonate that let's polarize because the CO bond gets stronger down the group. So what we'll write, thermal stability increases down the group because cation size increases. It's less polarization of anion. Or CO bond getting stronger. Moving to next part, D, a student electrolyzes a solution of Ki aqueous for 8 minutes using a direct current. The half equation for the reaction that occurs at the anode is given. 2I minus aqueous gives I2 aqueous plus 2 electrons. Number 1, write a half equation for the reaction that occurs at the cathode. Include state symbols. So you have to include the state symbols for this question. Recall potassium above in the reactivity series than hydrogen, then hydrogen must get discharge at cathode. So the equation must be 2H plus aqueous. It's a reduction reaction, 2 electrons, and we get hydrogen gas. This will be the final equation. Moving to next part. Number 2, after the electrolysis, the I2 aqueous produced requires 35 centimeter cube of 0.1 mole per dm cube Na2S2O3 aqueous to react completely. This reaction I2 aqueous plus 2Na2S2O3 aqueous gives 2NaI aqueous plus Na2S4O6 aqueous. Calculate the average current used in 8 minutes during the electrolysis. First of all, you need to calculate the moles of S2O3, 2 minus moles of S2O3 minus 2. So 0.1 mole per dm cube means 1000 centimeter cube contains 0.1 moles or 0.1 mole. Therefore, 21.35 centimeter cube contain X mole. So X becomes equal to 0.1 to the cross multiplied by 21.35 divided by 1000. So what we will get? We will get 0.002135 moles. Now you know that Q is equal to IT. Q is equal to IT, or we need to calculate the current. I becomes equal to Q by T. Time is given, which is 8 minutes. 8 minutes means 8 multiplied by 60. We need to take time in seconds. What about Q? You need to calculate the Q. In order to calculate the Q, so we need the moles of I. We need the moles of I. Here you can see the reaction. 2 moles of electron are released. So this will be the value for the 2 moles of electron. What about the moles of I? If you look at the equation, for 1 mole, for 2 moles, 1 mole is needed, which means half of the mole is needed for this value. So this will be divided by 2. So in order to calculate Q, we will write 0.002135 divided by 2, and this will be the number of moles of electrons, and this will be multiplied by Faraday constant, which is 96,500. So 0.002135 multiplied by 96500 is equal to divided by 2 multiplied by 2. You will get 206.02. 206.02. This will be the value for Q. So in order to calculate I, what I will write? I will write 206.02 and divided by 8 into 60. 206.02 divided by 8, again divided by 60. 0.429 ampere. This must be the final answer for this one. Part E. Ki is used as a source of I- ions in organic synthesis. One example of this is shown in the synthetic route in figure 1.1. We have A, B, C, D, as well as E. Let's see the questions. Number 1, identify the reagents required for steps 1 and 2. Steps 1 and 2. Where's steps 1 and 2? Step 1 and 2. Step 1, it must be nitration. Nitration involves the reaction of concentrated HNO3 in the presence of concentrated H2SO4, which is acting as a catalyst here. So nitronium ion must be coming from here. So you write concentrated HNO3 and concentrated H2SO4. What about step 2? Now step 2, what is happening? Is step 2. It involves the reduction to NH2. It must be SN plus concentrated HCl. SN is 10. So you write SN plus HCl. Moving to next part. Step 3 occurs in 2 stages. Stage 1, NaNO2 and HCl undergo an acid-base reaction to produce HNO2. Stage 2, HNO2 reacts with C6H5NH2 to produce D, C6H5N2 plus. Complete the equations for stage 1 and for stage 2. Stage 1, NaNO2 plus HCl. It's undergoing acid-base reaction, and one of the product is HNO2. So I will write HNO2. What else is left? Na and Cl is left. They will react together to produce NaCl. NaCl must be the other product. For reaction 2, this reaction between HNO2 and C6H5NH2. HNO2 plus C6H5NH2. C to D. Look at this. Where is C and D? Here's C, here's D. It must be having H positive ion coming. So I will write H positive ion also. What about the product? You will get C6H5 and 2 plus 2H2O. Number 3, the I minus from Ki reacts with D in step 4. The mechanism is shown in figure 1.1. Suggest the name for this mechanism. Step 4. So here's step 4. So what is happening? It is nucleophile replacing the another nucleophile. So it must be nucleophilic substitution. So you'll write nucleophilic substitution. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.